Hi, welcome to Lesson 12C, Vectors in a Plane. The goal of today's lesson is to understand the power of vectors in component and unit vector form. So, when we look at locations of things on a Cartesian plane, the locations of points, we have the location described by two components, an x and y component, and so suppose we have maybe some point, I'll make it over here, I guess, something like this maybe, and actually no, let's make it down here. There we go. So if we have this point here, that point we know is 1, 2, -3 and 2. So in order to arrive there, we of course would start at the origin, and we would move in the x direction first. We would move 1, 2, 3 units to the left, and then 1, 2 units up from that point to get to -3, 2. If we talk about transformation geometry, we can say that this point has been translated a units in the x direction and then b units in the y direction. And so a translation, or this point actually, can be seen as a translation vector in the form of a column vector AB. Okay, so remember I noted that yesterday in the last lesson. So the vector from the origin O to this vector P, or sorry, this point P, would be the position vector OP, which is equal to, in this case, -3, 2. Okay, so that's the vector that points us from the origin to that point. So it would be -3, 2. Okay, it's also called a translation vector because it's translating a point so many units horizontally, A, I guess, generally, and B units vertically to get to that point from the origin. Okay, unit vectors. Well, unit vectors can be used to show this as well. And unit vectors, the idea of unit being 1 unit long. Okay, so unit vectors are 1 unit in length. And so in the x direction, a unit vector is denoted by I, and in the y direction, the unit vector is denoted by J. Okay, and I guess because they are vectors, they need a little vector symbol up there. And because they're unit vectors, the unit vector I, the column vector for that would be 1, 0, and for the unit vector J, the column vector would be 0, 1. Okay, so we're going 1 unit in the x direction here and 0 units in the y direction, and for the unit vector J we're going 0 units in the x direction and 1 unit in the y direction. Okay, so then if we're to use this as a model, we could say that we're going, well, I could just break this up into a unit vector in the negative direction, and then another unit vector in the negative direction, and then another unit vector in the negative x direction, and then we've got 1 unit vector in the y direction, and then another unit vector in the y direction. So all of these things are all unit vectors. So we see we're going -3 unit vector i's, followed by 2 unit vector j's to get to that point. Okay, so we can write this in a number of ways. So vector OP can be written as -3, 2 as a column vector. We can also write it as -3 unit vector I plus 2 unit vector j, and therefore we can also say this, we could rewrite this as -3, 2 in column vector form, and that would equal -3 unit vector 1, 0 plus 2 unit vector 0, 1. Okay, and that would give us the same direction, the same endpoint as we would have with this column vector negative 3, 2. Okay, so these are just different ways of writing these things. So this would be the component form here. And this is unit vector form here. Okay, so that's about it for actually seeing how to write vectors in planes. Now, to get the magnitude of a vector, well, if we look back up here, we see that this shape is a right triangle. And in order to find this magnitude of this vector, well, that's, if we use Pythagorean theorem, we see that we could just use that theorem to find the magnitude there. So we could say the magnitude of vector OP, well, then that's just a matter of working through Pythagorean theorem. So it would be negative 3 squared plus 2 squared, and of course the square root of that. So it would be the square root of 9 plus 4, which is root 13 units. Okay, so that would be the magnitude of vector OP. Now, one other thing is, sometimes we might see vectors that could possibly be unit vectors. And a unit vector is basically one vector, or one unit long. Vectors, if I say vector v, we know that vectors have magnitude and direction. So the magnitude is what we just found, the magnitude of the vector, and that would be multiplied by, or given the direction of the unit vector, and unit vectors have this little caret on top. So we know that unit vectors are of 1 unit length. So if we wanted to solve for the unit vector, if we just divide both sides by the magnitude, then if you take a vector and you divide by the magnitude, that will give us the unit vector. Okay, so if we wanted to find the unit vector for this vector here, all we have to do is divide this vector, this unit vector, by its magnitude. So we'd get negative 3, 2 divided by root 13, and that would give us the unit vector. Normally it's written as the reciprocal of the magnitude multiplied by the vector. So this is a form of showing what the unit vector would look like. So that is basically it for 12C and 12D, and there's a little bit of work for you to work on in those sections. Basically 1 to 5 in both of those, 12C and 12D, and we'll look at a couple examples tomorrow in class, and then you have the rest of time to work on the practice questions, and even take a look at some of the practice questions, or sorry, some of the examples that are in the sections after watching this video. So thanks for watching, and we'll see you in class.